Thank you for that introduction, and I'd also like to thank the Focused Ultrasound Foundation for the opportunity to share my work with you today. The title of my talk this morning is Ultrasound Ablation Enhances Nanoparticle Accumulation and Survival in Mammary Carcinoma Models. The objective of this study was to combine MR-guided focused ultrasound ablation with liposomal doxorubicin and to track the kinetics of long-circulating liposomes following ultrasound ablation. Our animal model consisted of FBB mice implanted with NDL tumors. They are syngeneic orthotopic mouse models of breast cancer. Our N number for this study was between the imaging and survival studies was about 117. And for both imaging and survival studies, tumors were ablated with one of either three protocols: single point, a circle ablation, or a grid ablation. For the survival ablation studies, animals were ablated once weekly for 4 weeks. They also received liposomal doxorubicin twice weekly during that same time period. The liposomal dox consisted of either long circulating liposomes or temperature-sensitive liposomes, in which case ultrasound hyperthermia was also added to the protocol before TSL administration. The controls were no drug, no ablation, and no treatment. For the imaging studies, we looked at two different things. One was imaging immediately after a single ablation treatment, upon which copper-64 labeled liposomes were injected, and animals were watched at 3, 20, and 48 hours post-ablation. We also looked at a treatment protocol whereby animals were treated once weekly with ablation for 2 weeks and long-circulating copper doxorubicin liposomes, and after the third ablation treatment, they were then injected with the copper-64 liposomes. Our MR-guided focused ultrasound system is high field and high frequency. The setup is a 16-element annular array operating at 3 megahertz with a focal volume about the size of a grain of rice. The MR is a 7T Bruker BioSpec scanner. As I had mentioned earlier, we tried 3 different sonication patterns illustrated below. The acoustic power was the same for all of them, 5 acoustic watts. For the single point protocol, a single point was sonicated for 7 seconds. For the circle ablation protocol, the transducer ran for 30 seconds in a circular pattern of 2 millimeters diameter. And in the grid pattern, single points were spread out to cover approximately the entirety of the tumor. They were spaced by 1.5 millimeters per spot, between each spots, Here are some typical images of on the left, the single point ablation, and on the right, a circle ablation. These are MR thermometry images. What we found is that a single ablation treatment resulted in accumulation of nanoparticles up to 48 hours post-ablation. You can see on the right in the blue arrows, that was the ablated tumor, and the white arrows on the right are contralateral untreateds, and on the far left, those images are untreated animals that were not treated at all for either tumor. We found that the accumulation was independent of the protocol we used for the ablation, that is grid, circle, and single point ablation all showed enhanced nanoparticle accumulation in the ablated tumors compared to either contralateral controls or no treatment controls. Following the 48-hour imaging time point of PET, the tumors were sectioned and used for both autoradiography and histology. Autoradiography, the ARG column, in the image below, you can see that the greatest accumulation is within the rim of the ablated tumor. And in the no treatment, And in the no treatment, there is no noticeable accumulation on autoradiography. From histology, we can see that this corresponds with the rim of remaining viable tumor following ablation. So we're getting the maximum accumulation of the liposomes and of liposomal drug in the area where it's needed most, of the viable tumor. We also found that nanoparticle accumulation continues with treatment. Animals treated twice weekly with long-circulating liposomes show heterogeneous long-circulating liposomes alone, no ablation on the top row, show heterogeneous accumulation in their tumors. Animals treated with the same protocol, but with the addition of weekly ablation, so that is they were ablated 3 times, and on the third time, this is when they were injected with the copper-64 liposomes and watched. They show a greater and more homogeneous accumulation within the ablated tumor. After a 4-week regimen of weekly circle ablation and twice-weekly long-circulating doxorubicin liposomes, we observed complete local tumor regression in all animals. Single-spot ablation in combination with the same liposomes resulted in 25% local disease regression. Likewise, combined therapy using temperature-sensitive doxorubicin liposomes and circle ultrasound ablation resulted in complete local regression of the disease. And again, single spot ablation in combination with TSLs resulted in 25% regression of local disease. So in conclusion, nanoparticle accumulation is increased in ablated tumors, with the greatest accumulation appearing at the rim of the tumor, the remaining viable rim of the tumor, where it's needed most. We saw up to 50-fold accumulation compared to untreated controls. And this results in complete local disease regression when combined with chemotherapeutics. So I would like to thank Professor Kathy Farah, my lab mates, and funding sources, and thank you for listening to my talk this morning.
Thank you, Brett. Time for a very quick question and a very quick answer, so we're running over. Vic?
Yeah, hi, nice talk. Just quick question. Did you measure DOX levels in circulation, free DOX, in response to the treatments?
In the blood? In this study, we did not, but in previous studies, we have looked at that. I don't know the results off the top of my head, though. I believe because it's a copper doxorubicin complex, it was not quite as high as perhaps thermodox. But.
Real quick, Sasha?
Yes. Was your thermodox composition also with copper, and what's the composition? Maybe.
Yes, it did involve copper. Basically, the copper chelates the two doxorubicins chelate the copper, sort of like a sandwich. I think the
but
aromatics.
It was DPPC based.
Pardon?
It was DPPC based. The thermodox.
Yes.
Yeah. And does it leak while it circulates?
No, I believe the chelation of the copper actually helps stabilize the liposome as a whole.
Thank you.
All right, thanks, Brett.
Okay.
Great talk.
Thank you.